Regression and correlation. This is the analysis that we are going to describe whenever we are studying the two variable under consideration. If we have the two variables x and y, both of the variable are scaled in nature. One variable is assumed as a dependent variable and other variable is a independent variable. This is assumed to be the predictor, independent variable, and y is a dependent variable. We can find out the relationship or association between the x and y. That relationship is referred to as a correlation. The correlation is what? Correlation is nothing. It is just a relationship or association between the two scaled variables. If the two variables are associated positively, we have a positive correlation. It is represented by R. Sample correlation is represented by R, and population correlation is represented by letter rho. Rho is a parameter because it is a population constant, and R is a estimate or a point estimate. Point estimate of it is a statistic. The point estimate of rho is a sample correlation R. If we have a two nominal variables, suppose x and y. X is a nominal variable, y is also a nominal variable. The association between the two nominal variables can be checked by chi-square test of independence. So chi-square test of independence is used to check the association between the two qualitative variables, and correlation is used to assess the relationship between the two quantitative variables. Two variables which are used in this presentation are age of car and the price of car. Both variables are scaled variable, quantitative variable, and we want to check whether there is an association between the age and price of the cars. Response variable is the price of car, and age can be used as a predictor. The price will be the dependent variable and the age will be the independent variable. So age and price, these are the two variables. Age is a predictor. We may have the more predictor here in the analysis, but we are going to start by the simple version of the example in which we are considering only the two variables. Ages are given here: 5-year-old car, 4-year-old car, and the prices in hundreds of dollars are given here: $8,500, $7,100, and $4,800. 7-year-old car have a $4,800 price. So this data set, we have a sample of 11 cars, and we want to find out the relationship among these two variables. A scatter plot is a graph of these two variables. On independent variable will be taken on the x-axis and dependent variable will be on the y-axis, and analyze the pattern of the points on the graph. If we have a pattern like this, so we can say that we have a downward slope, and it is an indication that as the age increases, the price of car decreases. So we may have a association which is negative in relation. So this is called negative correlation, or we call it as a negative relationship. Negative relationship means what? Negative relationship means one variable is increasing, then another variable is decreasing, and vice versa. This negative relation have a strength if the points are very close to this line. This is the line of best fit that we have to be analyzed in the next slide, or in the next part of this presentation. If the points are close to the line, we can say that there is a strong relationship in between these two variables. If we have a points which are away from the line and high spread and the high scatter we have in the data, so we can call it as a weak relationship. So in this case, where we have a data of price and age of car, the points are looking as close to each other and they are very near to the suggested line. So we can say that there is a strong negative relationship among the two variables. You can analyze these graphs, these scatter plots. We have a strong relationship between the variables, but this relationship is not linear. So we can say that the non-linear relationship among the two variables we have. In the second graph, we have a very strong relationship, or we can say that it is a perfect relationship. It may have a relationship, positive relationship with the suggested value of 0.9 or above, or more than 0.9. This is non-linear relationship with the strong correlation. This is a negative linear relationship. This is a perfect positive. We can say that the relationship here is 1 plus 1. Positive 1 correlation we have here. It is perfect positive correlation. In the case it is in which we have a very high spread of points on the x and y axis, we can say that the relationship there is no relationship between x and y. So we can say that the correlation is 0 or quite closer to the 0. So 0 is indication of the two variables are not associated. There is no association, no significant association among these two variables. In this graph, we have a 1 correlation. If the points have a slight scatter, then we can say that it is 0.9. And further away points, we have 0.5 relationship positive. And if we spread the points more, then we can say that it is 0 relationship. So we can observe the strength of the relationship from left to right, and we have a 0 relationship here. If we move the points along the downward direction, so we can see that the relationship becomes stronger in the negative sense. The weak correlation here and very strong correlation at the -1 and very strong correlation at the +1. Highly negatively relationship and highly positively risky relationship, and no relationship we have. The two variables are not associated with each other. Correlation is highly related with the covariance. So how covariance is computed? Covariance can be computed by x minus mean times y minus mean total of the product divided by n. This is basically, we can extend this formula with the formula of variance. Formula of variance is what? Summation x minus mean whole square divided by n. This can also be written as summation x minus mean and x minus mean. The whole square can be written as x minus mean and x minus mean. So we can call it as a variance, or we can call it as a covariance between x and x. So the same formula we have here for the covariance. So if we have variance of variable x, that is x minus mean times x minus mean, that if we are changing the one variable y, then it is called as a covariance. So what the correlation is? Correlation is the ratio of the covariance and the two standard deviation. So in the simple word, we can say that correlation can be calculated as covariance between x and y divided by the standard deviation of x and standard deviation of y. So if we calculate the ratio of this, it is called correlation. If we have a data, sample data, then it is known as a sample correlation. If we have a population data, then it is called a population correlation. Population correlation is represented by rho, and sample correlation is represented by R. A point estimate of population correlation is the sample correlation. This is the sample point estimate. If the covariance is positive, means x and y are positively correlated. If covariance is negative, the sign of covariance is an indication of the sign of correlation, because standard deviations are always positive. That is only the covariance which may be positive, which may be negative, because the formula of covariance is x minus mean times y minus mean. If the x minus mean is positive but y minus mean is negative, then the product will be negative. Similarly, if x minus mean is negative and y minus mean is positive, then the product will be. If we have larger number of the product as negative, then the sum will be negative and the covariance will be negative. The covariance, negative covariance is indicating that we have a negative relationship and the flow of points on the scatter plot is downward. The downward flow can be represented by negative covariance, and the upward flow of the point on the scatter plot is an indication of positive covariance. So if covariance is 0, we can say that x and y have no association. That is an independent variable. So that is an implication of zero correlation. So if we have a zero correlation, x and y are independent. If then the covariance is 0, then the correlation will be 0. Covariance of xy divided by standard deviation of x and standard deviation of y. We can also write down this as sigma xy. Sigma xy is the covariance of x and y. And in the denominator, we have a standard deviation of x and standard deviation of y. This is the correlation, and that is a point estimate of population correlation. Population correlation, sample correlation. Sample correlation is statistics, while population correlation is a parameter. So this is population correlation, and this is sample correlation R. R is the sample correlation. Population correlation is a parameter, while sample correlation is a statistic. It is a statistic. correlation coefficient can be computed by the formula R is equal to sum of the product xy, the sum of x, product sum of y divided by n, standard numerator of the formula of variance x with the square root. And this is the numerator of the formula of standard deviation of y. The y denominators are not there. Due to the denominators will be cancelled out with this, with the denominator of covariance. We have a denominator of covariance here. We have a denominator of variance of x in the square root. We have a denominator of variance of y in the square root. That denominator will be taken outside, because if we have two denominators in under root, that can be we have a one denominator n without root, that will be cancelled out with the denominator of covariance. So this is the reduced formula, and this is known as computational formula of calculating the sample correlation. These are the characteristics of correlation. Correlation is unitless. Unitless means the units will be cancelled out. If we have covariance in centimeter, if we have a standard deviation of x in centimeter rho, and we have a centimeter here, so that will be cancelled out. So we have a relationship which is unitless. So there is no unit of measurement for the correlation. The range of correlation is from -1 to +1. Can any one of you tell me the range of covariance? The range of covariance is, we may have any number from -infinity to +infinity. So we cannot say anything about the range of covariance. It can be any number on the real number line. But as already you have idea about the standard deviation is always positive. The range of standard deviation is from 0 to infinity. Similarly, the range of the standard deviation of y is from 0 to infinity. The standard deviation, the minimum value of standard deviation is 0, and the maximum value of standard deviation is infinity. The standard deviations can be from 0 to infinity, but the covariance can be from -infinity to +infinity, and the correlation may have a number -1, which is a maximum number on the lower negative side, and it may have a number +1, which is a very high correlation or a strongest correlation. So the range of correlation is from -1 to +1. Closer to -1, the stronger the negative relationship, and closer to 1 is a strongly positive relationship, and 0 is the meaning of a no relationship or independent variables. Correlation can be calculated by this formula. This is the formula of covariance. This is the formula of variance of x in the root. So we can call it as standard deviation of x, standard deviation of y. SSXY. What is SSXY? Is the numerator of the formula of covariance. Sum of a square between x and y. So this is the sum of a square between x and y. So SSXY, this is SSXY. Sum of the product of the x minus mean and y minus mean. And it is SSX and it is SSY in the square root, because these are the numerators of formula of variances. This is the numerator of formula of covariance. Regression. If the dependence of one variable is explained by the independent variable, so we have a regression. And the equation of such regression is known as the regression model or the regression equation. If we have a strong correlation between the two variables, then the regression line will be a suitable line and will give us a better prediction. If we have a weaker correlation among the two variables, we can say that the regression line will gives us a poor estimate or will not be a good predictor. This is simple linear regression model with one predictor. Predictor is X and the response variable is Y. B0 and B1 are the two parameters of the model that are to be estimated. And there is one random factor in the model, and this factor is known as error. This model is called probabilistic model. So it is a case of, this is known as probabilistic model. The probabilistic model is what? Probabilistic model is a model in which we have random factor, random error. So there are the two types of model. One of them is known as deterministic model and other is called probabilistic model. The two types of models are what? Probabilistic model and deterministic model. This model, in the regression, we have a probabilistic model. This is a probabilistic model. And most of the model in the physical science, like in physics and chemistry, we have a deterministic model like F is equal to MA. F is equal to MA is a deterministic model in physics. If we increase the force, the acceleration will be increased with the constant mass. So M is basically the parameter of the model. So if I compare this model with the probabilistic model, so M is basically the slope of the model and there is no y-intercept. So B0 is what? B0 is a parameter which is an indication of y-intercept, and B1 is the parameter which is a gradient with the variable x or the x-axis. And error is the random factor in the model, error term. The scatter in the graph, the spread in the graph or the randomness in the graph is due to this error term. So if we have a deterministic model, so all the points will be on the linear line. So this is a deterministic form of the model. We have a regression model which is deterministic in nature. If we have a scatter in the data and we want to fit a best line, then we can call it as a probabilistic model. So that is a difference between the probabilistic and uh, deterministic model. This model is known as theoretical model and this is called estimated model. The conditional mean can be calculated. If we are calculating the conditional mean, then the mean of error will be 0. So we have B0 plus B1x. This is called estimated model, while Y is known as observed model. The observed model and estimated model, or we can call it as a theoretical model and estimated model. So after estimating the parameters, we have the values of B0 and B1. The B0 is the estimate of parameter beta naught, and B1 is an indication of estimate of the parameter beta 1. So beta 1 is a parameter, while B1 is the estimate or the point estimate of the parameter beta 1. And B0 is the point estimate of the parameter beta naught. So we can write down this as B0 is equal to beta naught is equal to B0 point estimate. The point estimate of beta naught is B naught, and the point estimate of beta 1 is B1. So our objective is to find out these two estimates. These two estimates can be obtained with the procedure of least square. The procedure of least square is a technique by which we can estimate these two parameters. On this graph, we have some points. The points are indicated by dots, black dots. These points are referred to as observed point because these are the observed values. And the points on the line is referred to as estimated points. The estimated points are represented by y cap, and the observed points are represented by y. The difference between the y and y cap is known as error. So the first value of error can be obtained by taking a difference between the first estimated point and the first observed point. Suppose I am assuming that this is the first observed point, y1, and this is the first estimated point, y1 cap. The difference, this difference is represented by e1. So what are the errors? Error are basically these differences. So this is the first difference, this is the second difference, E2, E3, and so on. Some of the differences or the sum of the errors are negative, but other are positive. There are some points where the error is zero. Suppose this is the point where we have observed point and the estimated point, both are the same points. So error will be zero in that case. So error have some assumptions. Sum of errors will be zero. This is one of the important assumptions about these errors, because the few values of the errors are positive, because some points are above the line and the remaining are below the line. The total will becomes zero. So this is the one of the important condition about the error, that sum of error will be zero and the sum of square of errors will be least. Sum of squares of error will be least. Sum of square of error will be least means if we are fitting a best line, then the sum of square of error will be least. If I change the line from the best fitted line to any other line, suppose I am drawing this line with the red sketch. So thus this new line will be closer to some point, but it is away from the most of the points. So the sum of square of error will not be the least value. So the sum of square of error will be least only when we have a best fit line. Assumptions of the linear model. The relationship between x and y is a straight line. Means we have a linear relationship among the two variables. The values of the independent variable x are assumed to be fixed, not random. So this is known as a controlled variable. So x is a controlled variable, and the only randomness in the values of y comes from the errors. The error term is important, and the error terms producing the randomness in the model. The variance of y at every point of x has the same distribution. The homogeneity of variances exist. The way errors are normally distributed. This is one of the very important assumption about the error, and the mean of the error will be zero, and the variance of the errors will be constant, which is sigma square. Errors are uncorrelated. There is no relationship between the different values of error, that are the successive observations. So errors are normally distributed with the zero mean and the variance sigma square. This is one of the important assumption about the errors. Errors follows normal distribution with the mean zero and the variance sigma square. This is the important assumptions about the error. Steps in mathematical modeling or in machine learning models. You have to specify the problem for what you are constructing the model. Suppose I want to analyze a model for the old prices of the old car. So I have to choose the variable, and the research problem is we want to build a model which gives us a better prediction of the price of cars, second-hand cars. After specifying the objective, we have to collect the data. We have to sample of, suppose I am selecting the price 100 cars and the prices of the 100 cars along with their ages. The age is represented by X. We may have the further variable like condition of car Z. So if we have a age of car and the price of car, these are the two variable, and condition of car is another variable we may introduce in the model. And we may have the several other predictors on which the price of car basically be related. So data collection is an important task. After collecting the data, we have to clean the data. If there are some missing numbers in the data, you have to remove the missing number. If there are some outliers in the data, or the extreme values in the data, you have to remove the extreme numbers, bivariate outliers and the univariate outliers. Bivariate outliers can be determined with the help of a scatter plot, and the univariate outliers can be determined with the help of the box plot. The box plot are to be constructed for all variables under consideration. Box plot for X, box plot for Y, box plot for Z, and the scatter plot between X and Y, scatter plot between X and Z, and scatter plot between Y and Z. So three scatter plots will be there, and the three box plot will be there. Box plot will gives us the idea about the univariate outliers, and scatter plot will gives us an idea about the bivariate outlier. Suppose this is the scatter plot of price of car and the age of car as described on the previous slides. Suppose I have 1 point here and we have 1 point here. So these 2 points are basically the bivariate outliers. Why they are the bivariate outlier? Because a 1 year old car having the prices in this range. It is suppose 75 lakh, $7,500. So this is the price of 1 year old car, but why the price of this car is very least or very low? So this is an outlier. That outlier is called a bivariate outlier. And the prices of the 9 year old cars are around these numbers. But why the price of this 9 year old car is too high? That is an outlier. So we have a bivariate outlier in the data. We have a univariate outlier in the data. You have to remove the both types of outlier from the data before model learning or before fitting the model. After cleaning the data, you have to split the data file into two segments. One segment is known as the training data. Other segment is known as the testing data. Suppose I have the data of 100 cars, then randomly distribute these 100 cars into two segments. One segment having the 80% data and other segment have 20% data. 20% data is referred to as this will be used for testing the model and this will be used for training the model. So out of these 100 cars, 80 cars will be used for the training purpose, and these 80 cars will be extracted and separated on the random process. So randomly 80 cars will be put into the training segment and remaining 20 will be in the testing segment. Training segment will be used to build the model. After spreading the data file, we have to propose the model. There is a list of model. One of them which we are going to discuss is a linear model. So LM, linear model or the regression model is a one of the simplest model that we are going to analyze in this presentation. The linear model, classification model, clustering model, neural network model, or we may have a time series model. So there is a list of model. We have to propose a specific model for the given situation. After model proposal, we have to learn the model. The model learning, model fitting, these are the two important terms, means model is to be built. So what is the main objective in model learning or model fitting? Estimating the parameters. So we have to obtain a parameter beta naught in the linear model, and then we have to estimate a parameter beta 1. So these two estimates are obtained. This process of obtaining these two parameters with this data set, with the training data set, is known as model fitting or model learning. After model fitting, we have to test the model using the testing data set and check the accuracy of the model. If the model is accurate, we will deploy the model and use the model for future predictions. Model testing can be done either by goodness of fit test, or we can analyze the model with the help of adjusted R square. So these are the two different techniques to model testing. If the model testing is successful, then we have to deploy the model and use the model for the prediction purposes. If it is not successful, then what to do? We have to repeat the process. What procedure is to be repeated? The model proposal. Suppose I was using the linear model, but the linear model will give us a poor estimate. Then we have to choose another model, like we may have to place a quadratic model or a cubic model or an exponential model, and then refit the model and test the model again. So this is an iterative procedure, and we have to follow these steps unless we have a accurate predictions. So these are the steps in modeling, and in linear regression, we have to follow these steps. Model learning. Model learning is basically the parameter estimation. So we have to estimate beta naught and beta 1. There are the different techniques of estimation, parameter estimation. One of them is known as the method of least square, and other them is the method of moments, method of maximum likelihood estimation. But here I am introducing the method of least square. This is called MLE, method of least square estimation. These are the different techniques of estimation, parameter estimation. What is least square? Least square says SSE should be least. What is SSE? Sum of a square of error. Errors are what? These are the errors. And error squares, these are the error squares. So error squares and then sum. According to the least square, this sum of a square of error will be least. So this is the technique that I am going to use to estimate the two parameters beta naught and beta 1. So in our model, the model is y is equal to b naught plus b1x plus error. So we should have to make error as subject. If we make the error as subject, so this will becomes y minus beta naught minus beta 1 x1 or x beta 1 x, y minus beta naught minus beta 1 x. This is error. If we are making the square of error, so we take the square on the both sides. So this is called error square. And if we took the sum on the both side, this is called SSE. Now the SSE is quite simple. So you have to calculate the error then square the error, and then sum the error. So according to the least square, this is minimum, or this is least for the best fit line. Yeah, to estimate the values of beta naught and beta 1, we need such values of beta naught and beta 1 which gives us a minimum value of the sum of square of error. So this is the technique which is generally used to estimate these parameters. So y minus y cap, this is error. yi minus yi cap. This is not yi, this is yi cap. Observed value of y and the estimated value of y. The difference between the two is known as the error. Error is squares and sum. This is SSE. Or we can write down in a simple pattern like this, the sum of a square of error. And as I told you, this is y minus b naught minus beta 1x whole square. So what is the next step? To estimate beta naught, we have to differentiate this SSE with respect to beta naught and equate to 0. We will get one complete equation. Second equation can be obtained by differentiating this SSE with respect to beta 1 and equate to 0. So this is known as the second equation. If I am solving these two equations simultaneously, we will get the values of beta naught and beta 1. These two values of beta naught and beta 1 are known as estimates of beta naught and beta 1. So the derivatives is to be computed and equated to 0. Equation number 1 will be obtained, and the derivative with respect to beta 1 is to be computed and then equate to 0. The equation number 2 will be obtained. These two equations are known as the normal equations. So the first normal equation, the second normal equation. These two normal equations can be solved simultaneously to get the value of beta naught and beta 1. So what is the summation y? Summation y is the total of the column of y. N is the sample size. Summation x is the total of the column of x. And summation xy is the product total, and so on, summation x and summation x square there. If we put all the total there, we will have only the two things unknown. One of them is beta naught, other of them is beta 1. Then if we solve these two equations simultaneously, we will get the value of beta naught and beta 1. The beta naught is a point estimate of beta naught, and B1 is the point estimate of parameter beta 1. This technique is known as least square technique of estimating the parameters. And these two equations are called the normal equations. Now we have summarized the formula of SSX. This is the numerator of the formula of variance of x. This is the numerator of the formula of variance of x. This is the numerator of the formula of covariance of x. So these two estimates can be obtained by beta 1 is equal to SSXY, the, the, the numerator of the formula of covariance, and the numerator of the formula of variance of x. So if I take the ratio of these two, that is the slope of the line, and intercept can be obtained by this relationship. So these are the two estimates, beta naught and beta 1. Firstly, we will get the estimate of slope or the gradient, and then we have to find out the estimate of y-intercept. The summary of these formulas are given here on this slide. Now model fitting. For the given data, we are going to fit the regression line. So you have to graph the regression equation and the data point to obtain the errors. To obtain the errors or get a perception of error, we have to plot the both of the things. Then we have to describe the relationship between the age and price. That can be done by correlation. And then slope and the intercept are to be obtained. So for this data set, two columns are constructed, x into y and x square, and their totals are to be computed. These totals will be used in the formula of slope and intercept. The formula of slope b1 is summation xy minus summation x into summation y upon n. The numerator is this and denominator is this. Slope is minus 20.26. So we can clearly write down it as beta 1. Point estimate of beta 1 is b1 and the value of b1 is minus 20.26. Minus 20.26 is indicating that the slope is negative, means we have a negative relationship. So the price of car will be decreased by $2,026 if it becomes 1 year old. For the 2 year old car, it will be double. 20.26 multiplied by 2 multiplied by 100. Why I am multiplying by 100? Because the prices were given in the hundreds of dollars. The $2,026 will be decreased in every year. That is the depreciation ratio. Every year, the price of car will be decreased by $2,026. Why it is decreased? Because it has a negative slope. Now y-intercept is computed. The value of y-intercept is what? 195.47. That is an indication that if the age of car is 0, then we have the price of car will be $19,547. That will be the price. So a predicted model will be this, or the estimated model will be this. The y cap is equal to the y-intercept 195.47 minus 20.26x, because y cap is the estimated mean or the conditional mean. Conditional mean can be represented by b naught plus b1x. So b1, the value of b1 is substituted, it is 20.26, and the value of b1 is substituted, it is 195.47 and x there. Why not error is there? Because it is an estimated model. From the estimated model, we have minimized the error. The predicted model is there, and in the part B, we have to calculate the price of car, which is 2-year old, and the 8-year-old. To multiply by 2, we have 154.95 times $100, and 8-year car will be 33.939 multiplied by $100. So these are the two values which we have calculated with the help of the model. Finally, the best fitted line is represented here, and observed points are represented here. This is the observed point, this is the estimated point, and this is error. So every time we are computing the error, some of the errors are negative, the rest of the errors are positive. The sum of errors should be 0, and the sum of square of error should be the least. So what intercept is indicating? Intercept is indicating that the 0 age car means the new car have a price of $19,547, and there is a depreciation of $2,026 per year. We can introduce the more variable in the scenario or the situation, because the model was quite simple if I am introducing only the age and the price. Age and price, these are the two columns. We can introduce the condition of car, so we can represent the age by x1. The condition of car can be represented by x2. The mileage of car can be represented by x3, and registration date of the car will be represented by x4, and what the owner is doing. Profession of the owner is the variable x5, and the number of owners of the car is x6. Some of the variables are quantitative, but some are qualitative, like the profession of owner is a qualitative variable. So we have to ignore this variable because is a nominal variable. We can ignore the registration date because age and the registration date are basically the same types of variables. So instead of keeping the two variable age and the registration date, so we can keep only one variable, that is age. So that model will can also be constructed. So we will discuss the multiple regression in the next video. Non-linear relationship, there may be the non-linear relationship, and if we are fitting a linear line on a non-linear relationship scatter plot, then the error will be high and we will not get the accurate prediction. So one thing is very important: by scatter plot, we have to analyze that whether the relationship is linear or non-linear. If we have a linear relationship, then the linear regression style or linear model can be used. If we have a non-linear relationship, then do not fit a linear model on that. The quadratic model, cubic model, polynomial model, or exponential regression, logarithmic regression, these are the other topics in the nonlinear regression. And that's all for this presentation. Thank you very much for watching.